folks, this is Coil again with a kind of off-topic video. I know it's been a long time since my last video, but I have been busy with a lot of side projects and had very little time to do videos or other repair work for that part. A week ago, my friend Tommy over at Arctic Retro sent me this. This is the memory card for a Laser200 computer. And he is going to publish his own video about this, and he come to a stop. He had this fault with this transformer, and he did, he repaired the transformer and stuff, but he sent this to me as I have more in-depth knowledge of analog electronics than he has, and this is a power supply circuit here on the side, because these memory chips here, they require -5 volt and 12 volt power supply, and that is derived from the 9 volt that is supplied to this, and the 5 volt is supplied via the standard 5 volt supply from the laser. And I don't have any laser computers, at least I don't think I do, and I just going to look at this and I'm going to send it back to him.
So after finishing up this video, I actually talked to Kjell, my friend over at Coil Retro Innovations, and he actually offered to take a look at this memory module and see if he could do some tricks to either fix the broken component or replace it with something else. So I'm actually going to send it away to him, and he'll probably make his own video about this. In that case, I will link to that video later or comment on it in another video sometime later.
This is the memory module that Tommy sent me, and it's from the Laser200, and he has been doing some work on this, and he has troubleshooting this part of the board, and this part of the board is actually part of the power supply, because this connector here only supplies 9 volt, and this is regulated down here to -5 and 12 volt that is needed for the 4116 memory chips, and of course the 5 volt is also here. But this circuit here is an oscillator. It's a very simple switch mode circuit that has a simple step up circuit to make the 9 volt to 12 volt, very similar to the one on the Commodore 64. And then it has another turn on this small transformer here that generates AC that is rectified and then regulated by a Zener diode to -5 volt for the -5 volt. And the primary voltage these chips are driven by is the 5 volt, but you need the 12 volt to set and make these chips change state. And I have to look up in the datasheet how much power is needed to make these chips work okay. But the problem that Tommy found was that one of the windings on this has, I think, 3 or 4 independent windings. We're going to look on the schematics in a second. And one of them was actually broken. And Tommy did make an attempt to repair this, but this is very thin wire and it's very narrow, and there are ways to repair these kinds of things. And one of the ways is of course to make the winding that is broken whole again, and very often these small transformers or drossels or whatever is broken when there is a bend on the wire, and that is often on the part where they either are soldered or right beside that. And he found a break on this and tried to solder it, and it didn't solve the problem. And another way to fix this is actually to try to make a new winding just outside the old ones and try to make this deliver enough power. And you can of course go a totally different road and try and find a replacement part, but to try to mimic this operation of this Drossel that is custom made and has all these windings, that's impossible. You can't find this replacement. It's not an off-the-shelf part. And of course you can go the totally different route with having a DC to DC converter and make the 12 volt and minus 5 volt with that one, and just get rid of all of these circuits. So there is several different routes that we can go on this. And the first thing I'm going to do is actually to try to measure out how this Drossel should work. I might desolder it. I know that Tommy had this out and tried to make the repair, and I can try to measure this in circuit, and if I can't manage that, I will take it out. And when I mean measuring this, I'm not going to measure the inductance in this. I'm just going to measure that there is a connection between the different points. This is the schematic for the circuit that I was trying to describe. And here you can see the minus 5 volt circuit. This is a totally independent circuit that is coupled here via a transformer coupling. And you have a simple one-way rectifier, and you have a simple circuit here with a 5 volt Zener diode that clamps this to 5 volts, and you have a drop resistor here of 220 ohms, and you have a small capacitor here and a small one on the other side to make up the filter. And this is totally adequate. And for the circuit for the 12 volt, you have this circuit here that switches on and off this Drossel and make the voltage in this point go higher. So this is voltage doubler circuit that is clamped to 12 volt. And this 12 volt gives the feedback to have a positive feedback loop in this loop. So this transistor actually switches on and off and makes a voltage, probably something along the line of this, or maybe it's something like this on the Drossel here to make this an AC voltage. So this is an oscillator circuit, and part of this oscillator circuit is this Drossel here, and this Drossel is marked as 0.44 microhenry, and that is a Drossel that is in this circuit somewhere. It's not on the transformer. I think it can be on the transformer, but there really is no reason for it to be. Yeah, because you can see that 1, 2, 3, 4, 5, 6 are the legs on this inductor, but this one, it should be clamped to the 100 micro and the 200 micro capacitors that is here. Yeah, it's actually this one. That is that Drossel that is here. You can see here that it's clamped between these two capacitors. So this is the 100 and this is the 220. So this is the 0.44 microhenry Drossel, and these are the circuits and the windings that should be on this part here. And that means that each of these legs has a pair that should be connected with about 0 ohms. And once I find the numbering on this Drossel, it will be quite easy to follow along with this. And there are a piece broken off here of the plastic, but I do think that this or this is pin 1. So that will be the first order of business to figure out. You can also see this printed circuit board has a lot and good points with a lot of solder underneath the solder mask, and that was not uncommon. A lot of the Commodore boards also have this, and they don't break. If you have this kind of padding underneath, they don't go bad, these traces. They are very thick in comparison to a lot of the other ones. And as I said, Tommy has figured out that all of these components here actually are working, and he has probably checked out these resistors and these capacitors. I did not ask him if he has changed them, but I do see some, I'm not really sure. But these components are probably all good anyway. So he found a fault, but I forgot to ask him where the fault lay. Probably it will be here, otherwise it wouldn't affect both these parts. But that I will find out. This is very small writing, of course, but this is the datasheet for the memory chip that is used, or a similar one. And I will get to page where it describes the voltages, and you have that. And you can see here that this is described. The VBB is minus 5 volt, VCC is 5 volt, and VDD 12 volt, and of course VSS is ground. And these voltages, how much power do they really draw? There we have to go way back in the datasheet, and you have also this that describes the minimum and maximum voltages for this, and it's between 4.5 and 5.5 volt on the minus and plus 5 volt, and between 10.8 and 13.2 on the 12 volt supply. But what about the power then? Oh, here you have EBB, that's the minus 12 volt, ICC is the 5 volt, and IDD is the 12 volt. And you can see that the minus 5 volt is microamps, 4 milliamps on the 5 volt, and actually on the 12 volt you have between 27 and 35 milliamps. When it's operating, and standby it's just some microamps. And you also have here, now it's about the same, this is the worst case. So worst case you have this, and then you have for the 12 volt you have 8 times 27, it's about 240 something milliamps worst case on the 12 volt. And if you take the 200 as worst case here, you have about 800 microamps of the minus 5 volt. So we are not talking a huge power draw here. I wonder if it's possible to see this. Maybe, maybe not. And this is the component in question. And here you have contact. And here you have contact. And I wonder which numbering this is following. Because these are the first 4 pins. And if I try to check if there is some strange thing going on, this was contact, and this is also contact, of course, but it's not direct, it's mega ohms, mega, and this, and between this and this there is just 1.6 ohms, and that's almost a short circuit, so that's winding is okay, and this winding is okay. And then it was, what is the next point? Okay, this and this. Okay, Then I have to figure out what is what here, and then I have to find some known points. I have this transistor here. I take this like so, and this transistor here has one point that goes to the winding, and on that side, and that is this one. That's the one that goes to the winding, and then there should be another one that goes to the winding. I do wonder if Tommy has made a small error here. I don't know what this leg here is supposed to be connected against. Yeah, and here you can see I have made a sketch of what I measured out of this trafo, and 1 and 2 make sense, 3 and 4 make sense, and I can measure them out and place them where they should be. It's easy to trace 3 and 4 back to the 1502 transistor and the capacitor, and the same with the NA3 transistor and the 9-volt line and the 1 and 2 winding. But the 5, I don't know. I know that Tommy lost a pin here and had to do an other connect on this circuit to make this wire that he fixed fit, but I can't really figure this out, so I have to try. But I'm going to take a chance that pin 6 is the one beside 5 and try it out from there. And spoiler alert, here you can actually see my big mistake live, where I measure out pin 5 wrong and mistake it to not be connected to anything. And then is 5, and 5 is not connected to anything. It's totally not connected to anything on this side of the board, and it does not seem to be connected to anything on this side of the board if it's not connected here. So pin 5 of this should be connected to this BA315, and that is a diode. Oh, this is so strange, because there is one pin missing here, and Tommy told me that this pin fell off, and this is connected together with pin 3 on this, so there is no drossel there. And 1, 2, 3, 4, 5, this is 5, and if this drossel is connected like so. There are several reasons why I am confused about this, and you can see here in the schematic that I have cut into the picture here that the dots that marks where the winding is entering into a transformer is missing on the 5 and 6 winding, so I can't really figure out what is 5 and what is 6, what should go to the diode and what should go to the ground plane on this. And I make the decision now just to connect what is known here as 5 to ground, as that is the closest pin, and that would be the logical 6, and I try it out from there. I do think that means if I just connect these two together, this will actually work, and we are going to test that hypothesis. And what I'm going to do now, I have the hole where the missing pin is, and I assume that this missing pin is where this wire should be originally. So I just take a small wire and connect 5 and 6 together to the earth plane, and then we just try to see where that gets us. I will try to connect this up to the 9-volt supply and see how things goes. I will take these for measurements, and I do have this one used for the plus supply, and this one for the minus. And I got this sketch from Tommy. He told me that this one was ground and this one was plus 9 volt. So I'm going to connect these up. This was actually a bit difficult because my clamps is not small enough to connect to that one. So I do actually have to make some sheeting. So Please forgive me here, but I do have to solder on some. Yes, I have to connect that like so. This one I think is okay to take like so. Yes, no problem. And I have to adjust my power supply 9 volts, and I limit the current quite low. And I connect like so. And I will measure with this. Hopefully it's possible to see. This is DC volt, and I can measure over here first. Oh, the current limiter has struck. Yeah, it's about 80 milliamps that runs here and now. We have 9 volt there. And where do we measure? I have these capacitors out here that should be 12 volt. They are 12. And minus 5. Where do I have minus 5? It's over the 47 microfarad capacitors, and that is these ones here. That one was not very good on me. And 47, there are 2 of them. Where's the other one? It's, yeah, okay, it's this one. No, so we are not getting out the minus 5 volt, we are only getting about minus a half volt, but the 12 volt is working, and that probably was working all along. Then I have to trace out the circuit, and of course my quick fix here could be wrong, but I do think that this was clamped here, but there might be other windings on this drossel. I'm not sure. And of course there could of course be some power draw out of this circuit that limits the power, because this is a very small draw power draw. So if there is some short in one of the memory, yeah, one of the memory chips could be bad, and that would draw the power down. Oh, I'm not thinking straight. Of course there is no power draw, then the voltage over the resistor, that what we have measured, is no difference on each of the caps, so there is no power draw in this circuit now. Okay, so this is the minus 5 volt, where we have minus 4.4 only, and that is connected to pin 1 on all the memory chips, and we can check that. We have our data sheet here. Pin 1 is VBB, and VBB is the minus 5 volt, yes. Yeah, but I can measure, I can take this on AC volt, like so, and try to measure the output of this drossel. That should be this pin and this. Yeah, and there clearly must be something wrong here. Either the frequency is so high that the meter can't read this, or there is some fault with the coupling we just did, or maybe a combination of both of them. So I will need to connect the scope to see what's really going on here. Here I'm measuring in the collector output of the NA31X transistor, and I'm not getting what I expected to get. I think the frequency is a bit high, and it's also drifting a bit. This can be due to a capacitor fault, or that the transistor is not switching a complete duty cycle, that it's not allowed to go into full off modus. And the peak-to-peak voltage is also a bit strange, but that can be due to the same thing, that the NA31X is not driven full on and off. what is more strange is that the duty cycle is a little too less symmetric to really drive a transformer. And I would expect this timing to be that this would be about a 50-50 duty cycle or something, as this is not a feedback loop with fixed duty cycle or fixed frequency. So all in all, we're measuring quite some strange things, and I think I will change the 10 nanofarad capacitor even though Tommy has measured it. And I will also try to reverse the coupling I did. Probably I earthed the wrong end of the transformer. So I will do some soldering job now, and we see where that leads us. I have now desoldered what I connected up here, and if I measure from this pin here, I do find a connection here, and on my meter here this shows up as 0.2 ohms, and when I measure to the other pin here, it clearly shows up as 1.9 ohms. That means that I was wrong. It's not this pin that should be connected to ground, it's this pin that is the other end of the transformer here. And that you can see here, this pin here should be connected to ground, and this up here is the diode. And here I'm measuring on the diode, and you can see that there is more resistance on the pin that should be connected to ground, because when I'm using the ohmmeter here, I'm measuring like so and not like so. So that clearly means that I was wrong. It's not this pin, but this pin that should be connected to ground. And then I think that's it. Just have a huge bunch wire here. I just connect it like so. Yeah, that should be okay, I think. And one thing I also done is change this capacitor here. When I measured this here on my PeakTech, this measured out like 12.6, and that's not terribly off, but when I increased the frequency, sometimes it decreased and sometimes it increased. Yeah, now it seems to, then it's, you can see that it's drifting. So I changed this to a capacitor that was exactly 10 nanofarads, and also these old ceramic capacitors can be a bit vulnerable to noise, especially in high frequency circuits. So I did put in here good known 10 nanofarad that has a plastic cover on top of the ceramics. Yeah, everything else is as Tommy left it. I have not had out this drossel as I was thinking. I have not done anything on the memory chips and the capacitors and stuff. They are like they were. I did have out this 220 ohm resistor, and that was to break this circuit here to not damage the memory modules if I was testing this, because this breaks the circuit here so it doesn't reach the memory chips. But no, I do think it's perfectly safe to test. I also had out the 5 volt Zener diode and tested that it actually was 5 volts. I can show you that in a separate video how you test Zener diodes if you want. Yeah, I just check this and this, okay. So I just put on my bench power supply to 9 volt. Switch this voltmeter over to volt here, and it's ain't it. I do have the ground plane here, and here is the 5 volt, minus 5 volt, and you can see it's minus 5.114. That's good. And we have 12 volt, that's over here. Yeah, 12.11. And of course the 5 volt is not supplied here as it is now, because 5 volt is coming to this interface. So if I measure over here where there should be 5 volt, you will see that there is nothing, because the 5 volt is not made by this board, but it's supplied into this connector somewhere. I have not gone into depth to this. Tommy had already done the work to tell me which of these pins that should be connected. And I can see that there has been done some work on these memory chips. I don't know if it's Tommy that has done that. He has not released his video on this yet, I think. This bodge here fixed this, and the reason for this bodge is of course that when this pin, actually it was this pin, when the wire here from the transformer loosened and break off, Tommy did not know where to solder it, so he was thinking that it should be one of the other connectors, and it's a very easy mistake to make. This actually took some work to find out of. I have ohmed every point in this and found every other point in this, and I also measured out these transformer parts to see if they were right. You have this 50 turn and 50 turn here on the transformer, and you have 10 turns on this one. So everything on this schematic is now checked out, and as you saw, it was working just beautifully. So I'm just going to pack this now and send it back to Tommy so he can test this as a memory card. At least now we know that the memory chips are getting the power that they need to get. But before I pack this, I will take the scope and show you how this should look with the open circuit when everything works as it should. Yeah, this was how it looked when we used the scope earlier and before we did any changes. And this is the final result. I was now measuring on the connector, same as last time, and you can see the duty cycle is now way better. It's not 50%, but this is how this is regulated, is how much this is on. And the frequency is now stable at 130 kHz. And the peak-to-peak voltage that you measure here is about 8.25 volt, and that is about to be expected when you have 9 volt in, and you do have the basis emitter that you can drive this down to, and this is 990 millivolt, and that is a good drive over this. So all in all, a result that is about to be expected when everything works as it should. And I also did a measurement with the 220 ohm resistor lifted and just measured over the transformer winding here. And here you can see that we have a peak-to-peak voltage of about 21 volt, and it's swinging about 0, so we have minus 10.2 volt as the lowest point. So this is swinging wildly. And the frequency is still 130 kHz, and it's about the same duty cycle, of course, but you do have a much larger span on this now. And this could easily be rectified to, yeah, not much more than minus 5 volt, but you could have probably got about, yeah, maybe minus 8 volt if you wanted. So this circuit actually works quite well, and it's doing what it's intended to do. And it's a bit of a strange thing that they've chosen a combined circuit where you have a transformer circuit here, and you do have a voltage doubler here for the plus 5 volt. But of course it's not easy to get minus from a voltage doubler, so one of the only ways to get minus voltage is this way. But you could of course have put another winding on the transformer and taken this out in the same manner of this. So that's it. Thanks for watching. Hope to see you again in my next installment. It will be maybe 3 weeks from now. I will have to do some more travels, and it's a very busy autumn for me. I hope you like the content. Please hit like and subscribe. I have still not reached my goal of 1000 subscribers, so I do think I have about 930 something now, so we're closing in, but I really want to reach the 1000 mark before the year end. And thanks to Tommy for sending me this circuit. So, thanks for watching. See you in the next one.